Decision trees and random forests are highly versatile algorithms of supervised machine learning with applications in the field of medicine, technology, and stock prediction. In supervised machine learning model, a training dataset comprising of labels or a correct set of answers is used to train the model, and the algorithm developed is used to predict accurate outcomes of test data. Now, decision trees is explained by applying a decision tree classifier to the iris dataset. This has label data which includes features that aid predictions and targets or labels. A box in the decision tree is called a node, and the layers determine the depth. The decision tree classifier uses a series of true or false questions that lead to the correct outcome. The answers to the series of questions about petal width, petal length, and petal width again lead to the correct prediction in this example. The principle behind the random forest model is that multiple uncorrelated models or individual decision trees perform better together than they do alone. Each tree of the random forest outputs a vote. The random forest classifier chooses the classification with the majority of votes. However, random forest regressor picks the average output of all trees. It is important that the group of trees are uncorrelated. The first method to ensure this is called bootstrapping. In the previous decision tree example, we fed the entire dataset to the decision tree classifier. The dataset included 112 data points, whereas bootstrapping feeds us randomly sample smaller subset to individual decision trees as training data. This may include repeats. So tree 1 has 71 data points, while tree 2 has just 67 data points. This ensures that trees have different training data sets, hence produce different models. Using bootstrapping to produce uncorrelated models and then aggregating the results is called bootstrap aggregation or bagging. The second method is called feature randomness. While decision trees split using the most important feature, random forest first randomly creates a subset of features. It then splits the node with the best feature in the subset. The previous decision tree started with petal width, so it must be the most important feature. But random forest tree 1 here starts with petal length. Say for example, to determine the first split, only features petal length and sepal width were considered. The petal length gave the best split, so it was selected. This process is repeated across nodes with different subsets of features, and it results in very different decision trees.